Welcome to Ratios and Proportions. Before we begin, let's talk about what a ratio is. I can say 3 boys to every 2 girls. That would be a ratio statement. And there's a couple different ways I can write it. I can say 3 to 2. I can say 3:2. Or I can say 3/2 and write it as a fraction. A proportion is 2 ratios that equal one another. So, for example, 4/5 equals 4/5. Duh. That's kind of blatant there, isn't it? But what if I said, does 4/2 equal 2/1? The way you find out is let's see if I can draw one. Butterfly effect. I know, I'm so good at drawing, aren't I? The butterfly effect asks if 2 times 2 is 4 and 4 times 1 is 4, does 4 equal 4? Yes, it does. That's how I know those 2 proportions are equal. Let's try another one. Let's try, is 6/10 equal to 2/5? Get my butterfly equipment out. Does 6 times 5 equal 30? And 10 times 2 equal 20? Are those equal? No. So the answer is no. They are not proportions because they are not 2 ratios that equal one another. What if I had 1/6? Does 1/6 equal 5/30? Well, let's get our butterfly out. 1 times 30 is 30, and 6 times 5 is 30. They are equal, so yes, that is a proportion. What if I had n/15 equals 24/16? I'm missing a variable here. Okay, well, we're going to still get out our butterfly. We know that because of multiplication glue, 16 times n is 16n, and 15 times 24, I'm going to need the calculator for this. 15 times 24 is 360. Don't forget to bring down your equal sign. Now, this goes back to one-step equations. I need to solve for n. The 16 is connected to n through multiplication. The opposite of multiplication is division. So I'm going to divide both of them by 16, and n equals, bringing up my calculator again, and it's divide by 6, no, let's try 360 divided by 16 is 22.5. And that's what n equals. And that will make those two proportions, or those two ratios, equal. Let's try another one. R over 8 equals 25 over 40. Get out my butterfly. R times 40 is 40R. Bring down my equal sign. 8 times 25 is 200, because 8 quarters equals $2. Okay, I need to solve for R. So I'm going to divide both sides by 40. That equals 1. R equals, now when dividing all these zeros, I can cancel these zeros out, and 4 goes into 25 times. Because 4 times 20 is 200, and 8 times 25 is 200, and therefore making those two ratios proportions because they are equal to one another. Now, just because they put in decimals, you're not doing it any different. Let me go on to a new page. What if I have 3.2 divided by 4 equals 2.6 divided by x? Same strategy. Get out my butterfly, and that gives me 3.2x equals, and then 4 times 2.6. Call up my calculator, if I can find it. Oh, calculator, oh, calculator. There it is. Hit clear, and I need to know what 4 times 2.6 is, Mr. Calculator, and that would be 10.4. I need to solve for x, so I'm going to divide both sides by 3.2. That equals 1, leaving me with x equals, where'd my calculator go? Divided by 3.2 is 3 1/4, or 3 25/100. Very good. Now, when we apply this, it's 6 times x minus 3 equals 14 times 7. When we do this, we have to apply our distributive property. We're going to say 6 times x is 6x, and 6 times negative 3 is negative 18, equals 14 times 7, 8, 2, 98. Okay, now I'm solving multi-step equations. I need to isolate my x, so I need to move the negative 18 over to the other side. I do that by the opposite, adding and subtracting, remember? The opposite of negative 18 is a positive 18. I bring down the 6x because I did not solve it. That creates a big fat 0 equals 6, carry the 1, 9, 10, 11. And then I divide by 6. And x equals 19.33 repeating. By the way, that is a rational number. It is not irrational because it does repeat. Let's do another one. I like these. 3 minus y divided by 4 equals 1/9. Calling out my butterfly. Just because the problem looks a little different, I'm going to say 3 minus y times 9 equals, and 4 times 1 is 4. Now I'm going to apply the distributive property. 9 times 3 is 27 minus 9 times y is 9y equals 4. Move my numbers over to the other side. The opposite of positive 27 is a negative 27. That creates a big fat 0. I bring down my negative 9y equals, the signs are different, so I subtract. 27 minus 4 is 23, and take the sign of the larger number, so that's a negative 23. I divide by a negative 9, that equals 1, and y equals negative 23 divided by negative 9 will give you 2.56. Okay, very good. Here we have a word problem that we're going to use proportions to solve. First, read the problem. Trent goes on a 30-mile bike ride every Saturday. He rides the distance in 4 hours. At this rate, how far can he ride in 6 hours? The very first thing when I know I'm dealing with a proportion, notice I have two types of measurement. I have miles and how many hours it takes them. And I first see that I have miles, so I'm going to say everything in my numerator will be miles, and everything in my denominator will be hours. I'm dealing with a proportion, so I know I have two fractions equal to each other. Okay, let's go back and check it out. Trent goes on a 30-mile bike ride. 30-mile bike ride every Saturday. He rides a distance in 4 hours. So let's see if that makes sense. He goes 30 miles in 4 hours. Okay, that makes sense. Let's read on. At this rate, how far can he ride? I don't know how far he can ride. That's my variable. How far? how many miles can he ride in 6 hours? So what this problem's saying is if he can ride 30 miles in 4 hours, how far can he ride in 6 hours? Well, we have a proportion. We have to find x. Let's get our butterfly out. 4x equals 30 times 6. If you don't know how to do it in your head, 6 times 3 is 18. Add the 0. Divide by 4. That equals 1. And x equals 4 goes. So x equals 45. Now go back to your problem and ask yourself, does this make sense? If he can go 30 miles in 4 hours, would it make sense to do 45 miles in 6 hours? Well, sure, if the hours increase, the mileage is going to increase. Okay? Let's do another word problem. June earns $152 in 4 days. At this rate, how many days will it take him to earn $532? Step 1, read the problem. Just did that. Step 2, you know you have a fraction. Set up your problem. I'm going to set up 3 lines because when working with word problems, we're dealing with different types of measurement. We have money and days. Money was read first in the problem. Days was read second in the problem. Now the question. The question is going to be our variable. How many days? I'm going to use D to represent that. Okay? Let's go back and fill in the rest. He earns $152. All money goes on top in 4 days. That's basically our rate. Every 4 days he's earning $152. How many days will he earn $532? Notice, because my money's on top, my money always goes on top, and my days always goes on the bottom. So let's go ahead and butterfly. 152 times D is 152. D is 2,128. I'm going to divide by 152. 152 over 152 equals 1. And bringing up 14 days, which makes sense. If it takes them 4 days to earn 152, it's going to take more days to earn more money. So it's going to take them 14 days to earn 532. The key to doing proportions is making sure you have your rate, money over days, time over distance, and making sure you keep all your numbers or your variable, whatever you're looking for, either in the numerator or in the denominator. Okay?